I want to work through quiz 6. Many of you did extremely well on this quiz, but some of you still have, I think, some misconceptions. So I would like to just be able to work through all of it fairly quickly so you can see how to do this properly. So most of the quiz was looking at f of x is equal to 4x cubed minus x to the fourth. So the first question asks for intervals of increasing. The second question asks for intervals of decreasing. So we need to look at our first derivative. Our first derivative here is 12x squared minus 4x cubed. So to figure out where these might be changing of increasing and decreasing, we need to find critical value. So we look to see where is this undefined. It is defined everywhere. So we set it equal to 0. So we solve 0 equals 12x squared minus 4x cubed, and then we factor out a 4x squared, and we're left with a 3 minus x. What now we have to do is set each part equal to 0, and we see that this is x is equal to 0 and 3. So now we create a number line, and we label 0 and we label 3. And we look to see where is this derivative. So remember, we're looking at the derivative here. We're going to see where is the derivative positive and negative. So we plug in number less than 0 into our derivative. So we plug in, say, something like -1. We see that in 4x squared, we plug in a -1, that will become positive, and over here that will also be positive, so this is something that is positive. We now check something between 0 and 3, say something like 1, we get, again, the first part is going to be positive, and the second part is also going to be positive. Plug in something that is now larger than 3, and we're going to get a positive times a negative, which gives us something negative. So what that tells us now is that our intervals of increasing will be -infinity to 3, or you could have written -infinity to 0 union 0 to 3. Now, on the quiz, I told you to use commas instead of the union symbol, but if you use the union symbol, great, I still give you points. Now, decreasing then will only be 3 to infinity. Now, if we move on to the next group of questions, we have concave up and concave down, or questions 3 and 4. So that requires us to use our second derivative. So the second derivative is going to now be 24x minus 12x squared. And again, we see where is this undefined and where does it equal 0. It is defined everywhere, so now we simply factor out a 12x and we're left with a 2 minus x. And so we set each part equal to 0, so we get x is equal to 0 and 2. So now we create a number line with just these numbers of 0 and 2. We plug things into our derivative and see if it's positive or negative. So things less than 0. So this first part here would be negative, and this part over here would be positive, so that makes us negative. Pick something between 0 and 2, say 1. This is positive. This is going to be positive, so it's positive. Now pick something larger than 2. This part is going to be positive. The second part here is going to be negative. So we get negative. So what we see is that our concave up interval is going to be 0 to 2, and our concave down interval will be -infinity to 0 union 2 to infinity. All right. And just as a note here on the quiz, I may have mentioned it on some of yours. I accidentally flipped the answers for questions 3 and questions 4, so I have graded it accordingly. But in case you look back to see the correct answers, answers are switched for 3 and 4. So now if we go on to question 5, it looks for relative/local maximums. So remember, if we're looking for a local max, we're thinking the local max, this has to go from increasing to decreasing. So we have this function is going to be increasing, and then decreasing. So the only place that this happens is going to be at x is equal to 3. A local min is going to be where our function is going to go from decreasing to increasing. Now, according to our graph up here, we never had that happen, so there are none. No local minimums. Then if we look at question 7, we're looking for inflection points. Remember, an inflection point, it's not just simply where our second derivative equals 0, it's where concavity changes. So concavity is going to change where, well, if we look at this, we see concavity changes here at both 0 and as well at 2. So concavity changes here at x is equal to 0 and 2. So there was 2 answers for there. Critical points, remember, so critical points, these are going to be places where our derivative equals 0 or where it is undefined. And so the derivative equals 0 at x is equal to 0 and 3. It was undefined, no place, so this is all of our critical values. And the last question required you to use L'Hopital's rule. So we wanted to evaluate the limit as x approaches infinity of 3x squared minus 5x plus 1 divided by negative x squared plus 7x. We do, I guess, quote-unquote, direct substitution. You see the numerator is going to go to infinity. The denominator goes to negative infinity. So we have to use L'Hopital's rule. So remember, L'Hopital's rule says I take the derivative of the top divided by the derivative of the bottom. So I just repeat the limit after taking the derivative of each part. So the derivative of the top is going to be a 6x minus 5. The derivative of the bottom is negative 2x plus 7. Again, I get an indeterminate form when I try to take this limit, so we repeat L'Hopital's rule, and so I now take the limit as x tends to infinity of 6 divided by negative 2, and this limit is simply negative 3. So those were all of the quiz questions. This is the type of work that I would be expecting you to show, especially down here with the limit for L'Hopital. So this is what I'd be looking for with L'Hopital's rule questions. So if you have any questions, please let me know. But again, many of you did very well, so keep up with the good work. And if you ever have any questions that you would like me to make videos for, please let me know.